Welcome to our lesson on graphs of modulus functions. So in this tutorial, I'm going to give you the best possible way of sketching modulus functions. Okay, so listen carefully throughout the whole lesson and you'll be good to go. All right, so let's start with a graph of y is equal to the absolute value of x, or you would want to call it y is equal to the mod of x, or y is equal to the modulus of x. They are all the same. Okay, so this is how the graph will look like. Okay, this is the graph. All right, so I'm going to walk you through all the steps to draw this graph. Now, the first thing that you do is to draw the graph or the curve of y is equal to x. Pretend that the modulus or the absolute sign is not there. Okay, pretend that the absolute sign is not there. So you sketch the curve of y is equal to x. All right, so if you don't know how to sketch the curve of y is equal to x, then this is what you should do. Okay, take any number for x. Okay, all right, you can say let x be equal to 0. All right, so when x is equal to 0, y will definitely be equal to 0. Okay, so this is the point. Then if you say that let x be equal to 2, then it means y is also going to be 2. So let's say 2, and then we have 2 here, so we get this point. Then you join the 2 points. Okay, so it will pass through the origin. Okay, so this is the curve of y is equal to x. All right, now when you have the absolute value by the x, it means that your curve cannot be a negative curve. Okay, so when I say a negative curve, it means it cannot come at the negative part of the y-axis. So what do you do? So what you do is that you reflect this part of the curve. Okay, so you reflect this part of the curve about the x-axis. Okay, so you reflect it like this, so you reflect it like this. Okay, and then you get this v-shape curve, this v-shape curve. All right, so that is the curve for y is equal to the absolute of x. That is how we sketch the curve y is equal to absolute of x. So at this stage, you might want to keep in mind that the curve y is equal to the absolute value of x is a V shape. Okay, is a V shape that passes through the origin. All right, okay, so let's see another example. So now we have the curve of the absolute value of x plus 1. Okay, but now we know how to sketch this part. Y is equal to the absolute value of x. We got to know that it is V-shaped. Okay, it is V-shaped. All right, then what do we do with the plus 1? Let's see. All right, so this is the curve itself. Okay, this is the curve that we are about to draw. All right, of course I've drawn it already, but I'm going to walk you through how to draw it. So the first thing that you do is that you sketch, you start from what you know, and at this point you know how to sketch the curve of y is equal to the absolute value of v. So that is the curve that passes through the origin. Okay, that is the v-shaped curve. All right, so you have this. All right, so this plus 1 here stands for the vertical shift. So when I say vertical shift, I mean how the curve will move upwards. Okay, that is it. So the plus 1 means move the curve upwards by 1 unit. So if the curve were to be plus 2, we would have moved it upward by 2 units. So that would be 1, 2. Okay, so the V-shaped would have been here. All right, so since it is plus 1, we just move it up by 1 unit, and now we have our V shape here. Okay, so this is the curve of y is equal to the absolute value of x plus 1. All right, so that is what I wrote here, that shift the curve upward by 1 unit. Okay, so that is what you do. Let's consider another curve. All right, so this is a bit different from what we've been doing. Okay, now if you have a curve like this, it can be split into two parts. That is this 2, and then you have the negative absolute value of x. Okay, so we have established the fact that the curve of y is equal to the absolute value of x is the V shaped. Okay, so the negative means go the opposite way, so to look like N shapes. Okay, so to look like an N shape. Okay, all right, so without the negative it is a V shaped. Okay, so when the negative comes, then it flips. Okay, so it becomes an N shape. All right, so let's see how this curve is drawn. All right, so you, like I said, you start from what you know. You know how to sketch the curve of absolute x. Okay, so that is what you sketch, the absolute x, but because of the negative you flip it, so it becomes like an N. All right, like an N. Okay, so that is how to go about it. All right, so what about the 2? This is positive 2. Positive 2 means, all right, so this end that we have, shift it upwards. Okay, 2 units. If it were to be negative 2, we will go downwards 2 units, but since it's positive 2, we go upwards 2 units. So 1, 2. Okay, and then we get our N shape. Okay, so I gave you a few notes. That is, you sketch the curve of y is equal to negative absolute of x. All right, so that is the first N shape that you get. Then you shift the curve upwards by 2 units. Right, how about we have a curve of this? Basically it follows the same principle. Okay, don't be confused that, okay, right now we have x minus 3. No, you don't worry, it's so simple. Let's see how it is drawn. All right, so the first thing that you may want to do is to consider only the absolute value of x minus 3. Okay, so that is what we are going to consider. Okay, no problem, let's consider it. Right, so we would, the next thing that we will do is that we will look for the y-intercept of this absolute value of x minus 3. Okay, now at the y-intercept, so all the points on the y-axis, okay, any curve that crosses the y-axis at that point, x value is equal to 0. So there is a general rule in mathematics that at the y-axis, x is equal to 0. Okay, so when we put 0 into this function, we have y is equal to the absolute of negative 3. All right, but the absolute of negative 3 from our knowledge of modulus is 3. Okay, so now we know that the y-intercept is 0, 3. All right, then after the y-intercept, what do? We equate the function inside the modulus, not the entire modulus. Listen carefully. You equate the function inside the modulus to 0. So that is, you have x minus 3 equals 0. All right, this means that x equals 3. Okay, so now you go to your graph and then you plot with the intercept and then the zeros of the function inside the modulus. Okay, so what am I saying? You come here, you have x equals 3, and this is the point x equals 3. Okay, then your intercept, your y-intercept occurs at where? At where y equals what? 3. So this is it, y is 3. All right, then remember that always the modulus is going to look like either a V-shaped or N shape. Okay, it's not going to look at any other shape except V-shaped or N-shaped for all linear modulus functions. Put this one in mind. So when we say linear, it means the power here is 1. I'll cover a separate video that will be on the modulus of nonlinear, and you see how that will go. But for now, for all linear, know that it is either a V-shaped or an N-shaped. Okay, all right. Now, since there's no negative here, we know that it's going to be a V-shaped. Okay, so we have this 3 here, and then we have the y-axis to be also what 3. That's what your y-intercept is. So you connect it to form a V shape. So you have this, you have that, you are done. That is the curve for y is equal to the absolute of x minus 3. But what else do we have? We have plus 1. Plus 1 means, I told you, all the constants that is outside the modulus stands for the upward or the downward movement of the curve. Now this is plus 1, so we move the curve upward 1 unit. Okay, so this is 3, we move it upward by 1 unit to 4. Okay, and then we are good to go. All right, so that is what I added here, that shift the curve upwards by 1 unit. So when you shift it upward by 1 unit, you get the curve y is equal to the absolute of x minus 3 plus 1. All right, let's consider an example. So we have this. What are we going to do? First, we will consider only the absolute part of the curve. Okay, so that is what we will do. Right, so we will consider only this part. Then we will look for the y-intercept. That is when x is equal to 0. Okay, when we put 0 here, you get the absolute of 6, which is 6. Okay, so you take that part, y is equal to 6. Okay, that's your y-intercept. Then we look for the 0 of the inner function. That is when you equate the inner function to 0. So let's equate the inner function to 0. Okay, let's equate to 0. As soon as you equate this to 0, you get 2x plus 6 equals 0. Okay, so that will give you 2x is equal to negative 6. X will give you what? Negative 3. So we have 6 and then negative 3. So you have your 6 here, you have your negative 3 here. Now this is a positive sign that is here. Okay, so it means it's going to be a U-shaped or a V-shaped. So you just draw it and then you are good to go. Okay, you draw it like this and like that. It means that is your curve of y is equal to 2x plus 6. But remember that we have negative 3 here. That means that pull the curve down, let it go down by 3 units. Okay, so if this is 6, it goes down by 3 units. Now this part also go down by 3 units, and then you get your new V-shaped. Okay, and that is the curve that you are required to draw. So this is the curve. All right, okay, so it's called y is equal to the absolute of 2x plus 6 or minus 3. Okay, so this is the plan. Whenever you are given the curve, look for the sign here. If it is positive, you know that your graph is going to be a V-shaped. If the sign here is negative, then you know that you are going to get an N-shaped.